Having the ability to deal with exceptions, to raise our own exceptions, to basically control how we want to deal with unexpected circumstances really improves our ability to write good code. And it's part of that theme of defensive programming. If you think about it, what I did in those examples was I thought ahead to things that could occur that might not be what I normally expect and thought about what I wanted to do in that case. So my example of looking at grades was saying, if there are no grades, how do I want to handle that? And plan ahead so that I don't just throw an error, I actually deal with that circumstance. We can take that idea and use one more tool from Python to think about how to do defensive programming to prevent circumstances from leading to unexpected results. And that last idea is something called an assertion. We talked earlier on about saying when we write good code, we include things like a docstring that says, here's what I assume the inputs are going to look like, and here's the guarantees I'll put on the output if you give me inputs that satisfy those conditions. But we never enforced that contract, if you like. We simply said, document what you're trying to do. We might want to be sure that the assumptions on the state of the computation really are what we expected. Not just for inputs, although that's a standard place to do it, but maybe more generally. And for that, we can use an assert statement to raise an error, an exception called an assertion error, if those assumptions are not met. As I said, could be on inputs, it could be in an intermediate state of the program where I want to check that I'm in the right place. I can do an assertion that says, I assert that the following should be true, and if it's not, raise an exception. A nice example of good defensive programming. Here's an example. If I go back to my idea of just taking average of grades, I could assert, using that special keyword assert right here, when I enter average, that I expect there to be at least some grades in that list. And so I can assert that the length of grades will not be 0. And what that says is, if I give an input to average that has a list of 1 or more elements, this statement will not be true because it won't be 0, it'll be bigger than that. And in that case, I'll skip past the assert statement and do the right thing. I'm safe to go ahead and do the division. On the other hand, if I accidentally give it an empty list, then, in fact, the length of grades is 0, the not statement is false, and since that is false, assert then will stop the execution, throw an assert exception with that message printed out. So it raises an assertion error when I get something I don't want, otherwise it runs okay. And what's nice about this is it's not going to stop execution as long as I give it legal things. And this is a simple way of enforcing the expectation I have for this function. That's a nice thing to have because I stop immediately. If the assertion's not met, I don't wait till I'm partway through the processing before I stop the execution of this particular procedure. So assertions are really a nice way of doing defensive programming. They don't allow a programmer to conclude. Let's start again on this slide. So assertions are a good way of dealing with defensive programming. What are the properties of assertions? First of all, assertions don't allow a programmer to control the response to unexpected conditions. It simply is going to ensure that execution halts whenever an unexpected condition is not met. Typically, we use it to check inputs. It's the standard place to do it. And you'll see in good programming often every function or every critical function will have an assertion at the beginning saying, here's what I expect in terms of the form of the input before it comes out. If I want to be really careful, I could actually use it to check outputs before I return a value from the function to avoid propagating bad values. And if you think about that docstring, I have an expectation on inputs. I have an expectation on outputs. Having an assertion both on inputs and on outputs is a nice way of being very defensive in terms of how I program things. The other nice thing is that having those checks does make it easier to locate the source of a bug, because I'm going to stop the execution as soon as I get an input that doesn't meet the specs of a procedure, and that tells me instantly that the bug must have occurred prior to the call to that function. And it's a little bit like doing that search I did in my earlier example, but using assertions to help me spot the places to find the bugs, rather than having to go in and put explicit prints throughout the entire procedure. So where should you use assertions? Well, these are some good examples of it. Our goal is to spot bugs as soon as they're introduced and make clear where they happened. So I can use assertions as a supplement to my testing, raising them anytime a user supplies bad input data. And good places to use assertions are to check types of arguments, to check that invariants on a data structure are met. This is a list of more than one element, for example. To check constraints on values being returned, and to look for violations of constraints on a procedure. For example, I say I expect a list to have no duplicates. Well, I could enforce that by actually doing a check and raising or using an assertion rather to stop the execution if I get to that kind of point. So using exceptions to control flow of processing through a procedure, using assertions to check conditions on inputs, outputs, and potentially intermediate values. Two valuable tools to have as you think about how to write code that is bug-free and does defensive programming to try and ensure that it's bug-free.